if you could just briefly tell us how the prototyping phase went, what did the very first stage of the entire project look like, and what specific tools did you end up using?
We absolutely had to understand the entire breeding cycle. These are precisely the sorts of factors that the average shrimp consumer is simply not aware of. This is actually quite a widely discussed topic within the European Union.
Hello everyone, my name is Kuba Orchik. Welcome back to our podcast, which is dedicated to the implementation of AI in production solutions. Today I've invited Tomasz Kowalczyk from Neurosys, our valued partner. Today we'll be discussing a fascinating project focused on measuring shrimp growth using advanced AI-based solutions. Tomasz, could you perhaps briefly tell us how you came to be involved in this kind of project? How did you get into a project connected with aquaculture?
Well, it's an interesting, quite a story actually, because the project started with a client who reached out to us because a local company that was originally involved in this project in the role of an AI solution provider, well, frankly, they simply didn't deliver. Well, because we had quite a significant number of publications and also articles that specifically addressed issues related to the counting of objects and even open source libraries that we had made publicly available. One of our employees actually came across them. Well, initially, the company attempted to use these very libraries that we had provided and which we ourselves had published under an open source license. Unfortunately, they weren't quite successful, and so they decided to reach out to us to get some assistance. We began discussions, and what truly started as assistance with the use of our libraries, it then evolved into a complete redesign of the entire solution and its implementation, and a much longer course, a much longer collaboration than everyone had originally anticipated.
Excellent marketing, which is simply based on pure knowledge.
Yes, that really worked out quite nicely. It worked out wonderfully, and it clearly demonstrates that it truly pays to share your knowledge and not keep it only and solely to yourself.
All right, then what exactly was the main challenge in this particular project, and what was the specific client problem that you were supposed to resolve?
Well, this was a really interesting problem because the entire project actually began as a partially research and development project, very typical scientific one, with a commercial element to it. Well, indeed, this project was financed by a research unit that is specifically involved with what is known as aquaculture, or rather with all the issues concerning the study of the processes involved in the cultivation of fish and shrimp. In our particular case, it was specifically shrimp. Well, this was a project carried out in cooperation with a shrimp farm which operates in Germany. And the goal was to improve the breeding processes. Shrimp farming in Europe is quite unusual, actually. Most of the shrimp that we consume, yes, comes from warm oceans, rather from the seas and oceans of the coasts of Asia. Europe isn't a typical environment for this, but there are indeed certain arguments as to why it makes sense. However, the optimization of these processes is crucial here. Well, since the breeding process or the entire breeding cycle takes several months, its effectiveness truly depends on a great many factors. The aim here was to develop a solution that would allow us to monitor all the elements influencing the overall efficiency and optimization of this entire process.
Okay, if you could just briefly tell us what the prototyping process was like, what did the initial stage of the project involve, and which specific tools did you utilize?
Prototyping source Postgres touchpoints. First of all, we really had to understand how the cultivation works, and see it firsthand. Because the farming takes place in these special tanks, with warm water in an enclosed space. The process, we really had to fully grasp the entire cultivation cycle, how these shrimp are maintained at each specific stage of their development, under what precise conditions, and what various factors come into play. From simulating the night and day cycles, because that's also achieved through lighting.
You have truly become specialists, in actual fact, primarily in the cultivation of shrimp.
I learned a lot of interesting things about shrimp farming. For example, stressed shrimp are a very big problem in their farming. I'll probably have a chance to explain why later. But in the meantime, as a side project, we also developed an algorithm to detect the stress levels of shrimp. Well, these are precisely the factors the average shrimp eater isn't even aware of. And these are incredibly interesting topics, at least for me. So first, we really had to understand this process and then actually prepare a concept for a solution that would utilize image analysis algorithms. This was so we could truly monitor certain parameters in real time, because that was the key problem. Monitoring, well, the entire project was actually focused on real-time monitoring of the shrimp biomass. So to put it simply, we want to know, and we want to know constantly how these shrimp are growing, how quickly they're growing, how many of them there are, what the mortality rate is, because that's also very, very important. Until now, without artificial intelligence, this was only possible at the end of the process, when shrimp are harvested, weighed, and then we know the total biomass produced in such a cycle. But we, and mainly the client, wanted to be able to measure and monitor this constantly throughout the several-month breeding cycle.
Could you perhaps tell us a little bit more about the technical details of the entire project? I mean, what specific types of tools did you actually use? What particular kinds of cameras were employed? And which exact AI model was utilized for counting all these shrimp?
The project has actually gone through several iterations, and we are still developing this project now, bringing it from a more, let's say, research-oriented phase to a commercial solution. So the first version of this system was primarily based on cameras, which are suspended above individual tanks, above the specific pools where these shrimp swim. These cameras are quite unusual, and that was actually the client's choice due to ease of installation. These are, the actual cameras that are used in phones, like the iPhone.
So basically, there are only iPhones there?
Yes. The whole point was truly because we have here a very humid environment, water tanks where the humidity is extremely high, and also very unusual lighting and light reflections from the water surface, in which thousands of shrimp are constantly moving. Well, the whole point was to verify this particular solution and the entire concept itself as quickly as we possibly could, at the absolute lowest possible cost, without having to invest significant, substantial financial resources into camera installations, computing units, and things like that. So the concept here was simplified BIOS, meaning that the cameras that are being used are actually cameras from iPhones, for which we developed a special application that manages these cameras. It regularly takes photos, transmitting them via Wi-Fi, which was already available on site at the client's location, to a central server where processing, analysis, and various data aggregation operations are performed, displaying or presenting them to the client, including integration with a system for such a specialized system for managing the shrimp farming process. So there are many components operating in a very unusual environment, but it worked out and really gave great results.
Is the challenge, the sheer enormous quantity of shrimp in a pool like that? All those individual elements that you have to track and then evaluate. Was that the main problem?
Indeed, there were a great many challenges involved, from all sorts of purely optical problems, like various reflections and shifts in illumination. We had to cope with both the daytime lighting, when the shrimp experience an artificially simulated day, as well as the nighttime lighting, where there is significantly less illumination available. Here we have water, and we're actually observing, or the camera's looking down at the water's surface. Inside we have shrimp that are moving really very quickly, especially when they are being fed. These shrimp can swim incredibly fast underwater. However, we only see the top layer of the shrimp. Besides that, we know that these shrimp can swim at various depths. So actually, the vision system was utilized for the purpose of determining the exact number of shrimp within that very first layers. Based on other scientific publications, we were actually able to estimate the shrimp populations in the lower layers and their overall quantity. and also in combination with an infrared gate, which measures their mobility underwater in this layer where we can't see them, so we can truly make use of all this data. Besides just counting these shrimp in that first layer, we also had to measure every single one. Well, to assess the weight of a shrimp, it's not enough to know how many there are. We also need to know if there can be a large variability in their length, and that length directly translates to the weight of a single shrimp. So we had to count them, then we had to measure them. However, we also had to deal with all sorts of disturbances. Well, when we have shrimp swimming one above the other or one below, very often in such a picture they overlap. They often obscure each other, and they can also move very quickly, so the image might be blurred. And also preparing a model that recognizes and measures these shrimp, well, just in such conditions in itself was quite a challenge. The combination of all these data points with the motion sensor, specifically the infrared one, with the estimation of the quantity of shrimp at various depths, was a truly interesting challenge. And that's not even mentioning the purely engineering challenges we encountered along the way.
This sounds like a rather complex multi-layered installation with many different devices. As far as I recall, the client you're working with is located in northern Germany, while you yourselves are based here in Poland. Does this entire system operate without any failures, or do you frequently need to visit the client at their site?
No, this system fortunately works so reliably that we don't have to go there often. We really have the team that works in this shrimp farm is a team of true enthusiasts and also scientists. Well, actually, the founder of this farm and its main owner is a man who also holds a doctorate in marine animal husbandry. So he's not only an incredible specialist, but also a true enthusiast. And it really worked out very well, the sharing of responsibilities and expertise. What we really did after configuring this hardware layer, after installing all the necessary components, we truly concentrated on the algorithmic part. However, all potential issues related to on-site support were taken over by the client and their staff. And it really works very well, and it delivers excellent results.
You've implemented this solution and it's working. Do you have the next steps already defined? You mentioned you're moving towards broader commercialization. In what direction do you think this project will develop?
In fact, within the scope of this initial project, specifically the analysis of biomass, this was essentially the first phase, a tool for monitoring and tracking specific types of trends with the aim of streamlining this process and verifying which factors have a positive or negative impact. After this part, there were several subsequent stages, which were also carried out in cooperation with the Alfred Wegener Institute, that research unit concerning the detection of certain types of diseases. This is actually very important, but also stress. I'll talk about that because it's at least very interesting to me. Very often in this type of farming, certain kinds of diseases occur, whether it's shrimp or fish, because we actually worked on those topics with them as well. Vision systems can be used to detect certain symptoms of these diseases, whether it's shrimp or fish, at an early stage, in order to isolate them from the rest of the population. However, a particularly interesting side project, to put it in English, was precisely the detection of stress levels. Why is this important? Because it turns out that that shrimp that are very stressed have a very significantly higher mortality than normal shrimp. And many things can stress them, from bad food to too high a density of shrimp in such a tank. Then indeed shrimp without enough living space can become incredibly stressed, and their mortality can increase several-fold. So we utilized the system of cameras and vision algorithms that we already had to actually detect signs of stress in shrimp. And a stressed shrimp, surprisingly, changes the color of its tail from transparent to red. It's very apparent. I also found it to be a very interesting discovery that indeed shrimps with red tails are stressed shrimps. But by knowing the current population, the overall size of the entire population, and by understanding the population of stressed shrimps, we are able to very quickly detect that something is amiss and that the parameters of this particular farm need to be adjusted. And really here, this farm is able to, thanks to this, greatly optimize and increase its breeding efficiency by reducing mortality. However, now we are moving forward. This means we are actually working with this farm on the next stage, which involves the preparation of a commercial version of the product that can be offered to other clients. And here we are already talking about solutions that must be firstly easy to install, and they must have a very high level of operational stability when operating in very difficult and diverse conditions. So we're already working with other cameras as these data gathering sensors, utilizing a different type of lighting, which is simply more universal and can be effectively employed across a much wider range of various locations. And also additional analysis, which can be integrated into various other software solutions used for managing such a farm.
Okay, so perhaps one final question. You've developed a great solution to support shrimp farming. Could a similar solution be applied to the farming of other animals like fish, poultry? Do you have any experience or ideas regarding this type of application?
Yes, we have already worked on such subjects, for instance, in fish farming, not so much in the detection of biomass, but rather in identifying specific types of diseases. And indeed, these kinds of topics are appearing with increasing frequency. This is actually quite a popular subject throughout the European Union. There's a category called animal welfare, which means ensuring that during the breeding process, these animals, first and foremost, have the best possible life, but also that we diligently care for their health, detecting any diseases as early as possible so that they don't spread throughout the entire breeding population. So these kinds of important topics do indeed frequently come up. We actually we've been carrying out projects concerning fish. We're indeed receiving more and more inquiries from other areas, specifically chicken farming, cow farming. Well, we also once worked on a particular topic. Actually, we were approaching the concept of detecting a certain specific disease among cows, which is usually detected by people at a very late stage when there's not much that can be done. We can use AI algorithms for this, which are able to detect the first symptoms of this disease much earlier than humans and prevent it before it actually develops. So there are more and more such topics. However, these are unfortunately topics that require quite considerable investments for the sensorization of these very farms, specifically with special cameras, motion sensors, and so on. Unfortunately, these expenditures represent quite substantial costs.
iPhone's not cheap too.
The iPhone isn't cheap either. That's true, yes.
Tomek, thank you very much for our conversation today. Congratulations on your excellent project, and I truly hope we'll have the opportunity to invite you back with more projects in the future. Thanks.
It was a very great pleasure to be here. Thanks.